So in this video we're going to be going over t-tests and ANOVA, and we're going to be using R Commander to do that. This is our data. The CAMI is the community attitudes towards the mentally ill. There are some factors within it. Benevolence, so we have a post-test of CAMI. We have the pre-test of CAMI, sorry. We have benevolence pre, benevolence post. We have ideology pre and post. We have social restrictiveness pre and post. And we have authoritarianism pre and post. And then I also have a change score in here. We have the sites where these people were at. So the idea behind this study was that if we include topics dealing with, and it was actually if we integrated into a introductory to special education course, if we integrated them watching movies about the mentally ill and writing a paper about it, if that would somehow affect their scores on the community attitudes towards the mentally ill. So our independent variable in this case was the addition to some of these classes in, actually no, we were primarily interested in, sorry it's been a while since I've done this study, we are primarily interested in, does an introductory special education course affect their ratings on, we did a separate study where we did the videos. This was just, does an introductory special education course improve a person's attitudes towards the mentally ill. So our grouping variable then in this case is going to be the site, and so we're going to determine whether or not, depending on site, this would be different. So one of the leading questions here, we have Clemson, which is a land-grant university. It's a public university. We have Anderson University, which was a small Christian-affiliated university, and we have Southern Wesleyan University, which was another even smaller Christian university. So essentially we could see if there was a difference between the scores and based on the type of school that they went to. So we know from prior research that religiosity has an impact on the CAMI, or at least on people's mental health, what's the word that I'm looking for? Views towards the mentally ill. So people that tend to have, and this again is generalization, so I'm not making any declarative statements and saying that you're wrong for believing what you believe in. What I'm saying is that we have found through previous research that more affiliation with religious institutions results in a more authoritarian and socially restrictive view of persons with mental illness. So this is the data set. So what I want to do is I want to open RStudio. And I want to go down here and I want to open R Commander. Did I pass it? There it is. So I did R Commander and R Commander Miscellaneous. And there's my R Commander window. So the first thing I want to do is I want to import the data, and we're importing from a text file. We want to make sure that we click that the commas are the delimiter, because this is a comma separated value or a CSV file. And then I'm going to find my data set. And we'll be using the camidata.csv. So now that that's brought in there, I can view the data set once again, and we can see that we have pre-CAMI, post-CAMI, and all the various things. So the first thing that I want to do is I want to test for normality. So I can go to summaries, and then I can go for table of statistics. and I want to pick, let's just pick a post test. So let's go with post Cami, and then we'll do site, and we want, I think this gives us everything that we wanted to. Nope, this just gives us the scores at each of the institutions. So this is the mean for Anderson at post-test, this is the mean for Clemson at post-test, and this is the mean for Southern Wesleyan at post-test. So I want to find out, let's see if this does it. Yes, we want skewness and kurtosis. So I clicked on numerical summaries, and then I clicked on statistics, and I did skewness and kurtosis. And then I want to go back to that same test, which was the post-Cami, and I click OK. So we see that our skewness is 0.452, our kurtosis is negative 0.02. So we're within that 0 to 2 area that we were looking for. So we passed that assumption of normality. Now we're going to go to the Levine's test and determine our post-Cami with site 1. And had this test been significant, we would have had, it would have meant that variances were not equal across groups, so we would have violated the assumption of homogeneity of variances. But we're not significant, so we're okay here. And so now we can move on to those other tests. And so I'm going to go down to means, and I'm going to go to, well, first let's see if there was a difference from pre to post. So all schools, we're not grouping anybody, we're just seeing if there was a difference from pre to post test. So I would pick the pre-test variable, which is pre-Cami, and then I would pick the post-test variable, which is the post-Cami, click OK, and we see we have a t of negative 2.9, and this was significant. So there was a change from pre-test to post-test for each of the individuals, but that's not really telling us everything we want to know. So we could go and we could do an independent samples t-test, but this is only going to give us gender, because an independent samples t-test is going to look at dichotomous variables, or 1s and 2s, or 0s and 1s, or in the case of R, A's and B's, or B's and C's. And so the only time that we have that here is that we have it for gender, which was dichotomous. Because we had 3 schools, we can't do an independent samples t-test. But we can do it on gender, and we can see if gender had an effect on the post-Cami. So let's see. Nothing happened. Let's try it again. Okay, so here we go. The mean in the group of females was 151. The mean in the group of males was 148. Our t was 0.69, and our p-value is 0.493. So that tells us that there was no significant difference between males and females on that test. So now let's move on to ANOVA, and we would be essentially working with the same violations of assumptions. And so we would go up here to means. We would do a one-way ANOVA. And then our site is going to be our factor, and then we're going to do it on post-Cami change. So we look at our ANOVA table down here, and we see degrees of freedom was 2 and 72, the F value was 6.519, and we had a significant score there. And we can see that Anderson scored much less on, as well as did Southern Wesleyan University, on the test than did Clemson. So this could tell us that we changed those scores based on, or that we had differences in these scores just based on the Introduction to Special Education course. So had we not violated these assumptions, had we had we violated the assumption of equal variances, we could go down to a one-way ANOVA, and then we could select the Welch F test for not assuming equal variances, and then we would do the same thing here, and we would see that we have that our F value changed a little bit. So we had, assuming equal variances, we had an F of 6.519, which was significant. Assuming non-equal variances, we had 5.8903, but still significant. So this is a way of making this test, I guess, a little bit more robust. So if we had non-equal variances, if we had violated the assumption of homogeneity of variances, which was told to us up here with the Welch two-sample test, had this been significant, had this been under 0.05, we would have needed to do this here. Now, another way that we could do this is through a non-parametric test. And those non-parametric tests are down here. So we could do a Kruskal-Wallis test where site was our, and then we did post-Cami. So if our skewness or kurtosis were way off, or if our homogeneity of variances were way off, we could go ahead and use the Kruskal-Wallis test. And that is giving us a chi-squared value of 11.15. Our p-value is, again, still significant. We could also use the Wilcoxon signed rings test. No, we couldn't, because we have more than 3 values on there. So this gives us a general overview of the ways that R Commander can help us with this data. So again, the first thing that we do is we test for assumptions of normality. That would be through the, how do we get there? We got there through numerical summaries, and then we picked the measure that we were wanting to use, and we made sure that we did skewness and kurtosis on there, and that gave us whether or not we were working with a data set that was based on a normal distribution. The next thing we did was we did the Levene's test, which was under variances, and that Levene's test then told us whether or not we had homogeneity of variances across the factors. So Clemson was normal. Clemson and SMU and Anderson were all, the variances were all pretty similar. So we were okay to go ahead and do these other statistical tests. Had they been violated, we would need to go to a non-parametric test, or we would need to go to the more robust Welch test. So that should give you an idea of how we run these things in R. I would recommend that for, obviously this is easier than it shows in the book, but again, it relies on R Commander working and having the data set up. One of the big switches that's going to end up happening, or one of the big things that could end up happening, is if you used a numerical dichotomous variable. That means that so when I view my data set, had under site, if this was a number, we would have needed to change that in to reflect a string value or letters instead of numbers. And so the easiest way to do that would be in Excel. So if I went into Excel and I brought up that data sheet, which I can do real quick. So if I select this column, and then I go over here to edit, and then I go to find and then replace, it's only going to find and replace what's in that column. So I would find Clemson, and I could replace that with a C. So if this had been numbers, I would just put in the number there, and then I would replace it with the letter that I wanted to do. And then I replace all. And it takes it a second to get up, but you can see it changed all those to C's. And so if your factor isn't working, or if it, because our commander will actually know whether or not you have the right stuff. So if these things are highlighted out like we're seeing here with this 2 sample proportions test, that means your data is not set up in a method that it would allow for these things to happen. And so because we're showing up all the things here, that means that we're able to do this analysis in our commander because our data is set up in a way that it can understand it. So when these things aren't highlighted, it's generally because we don't have a factor listed that has alphabetical data rather than numerical data. I know this is really quick, and R is going to take some fighting, and so my suggestion to you would be to make sure that when you're looking at this data that you play with the data set and that you can come out with the same numbers that I'm coming out with. So did you come out with 5.89? Can you go through this and come out with 5.8903 on the post-cami with site 1 and site 2? We can also do a post hoc test. That's not really a post hoc test, but it is giving us a, so Clemson versus Anderson, Clemson was higher by 17. SWU versus Anderson, SWU was higher by a little bit, and SWU versus Clemson was higher by a lot. That didn't really give us the... So if we want to get a post hoc test on the model, what we're going to find out is that it's just a little bit more complicated, and we actually have to write a little bit of code. So what we're going to do is we're going to do Tukey's post hoc test, but we have to find out what the name of our model was. And so if we look up here, we can see ANOVA model.3, and that was the last model that we ran. We can also, when we run the ANOVA, we can change the model up here. So I'm going to name it Timmy. Okay, and so my model is named Timmy. And so now I can go down here and go Tukey HSD, and then I just put in the name of my model, Timmy. And then we can see Clemson versus Anderson had a difference of this, the lower and upper bounds are this, and then the p-value is less than 0.05. So we had a significant difference between Clemson and Anderson. Between SWU and Anderson, we didn't have much of a difference, and between SWU and Clemson, we had a large difference, but it didn't border on significance because this was less than 0.05. So when we go to write up our results of this thing, we want to tell the reader what type of analysis we conducted. This will help them make sense of their results. You also want to tell your reader why this particular analysis was used and what did your analysis test for. So an example would be a one-way between subjects ANOVA was conducted to compare the effect of the IV, which was Introduction to Special Education course, on the CAMI, on the Community Attitudes Towards the Mental Illness. So one way between subjects ANOVA was conducted to compare the effect of an introductory special education course on the Community Attitudes for the Mentally Ill survey. A significant difference between conditions. There was significant or not a significant effect of introduction to special education on results of the CAMI at the P05 level for the conditions F, and then we would get the 2 from the between groups, and we would get the 12 from here, so the degrees of freedom are 2 and 12. 4.94 gets brought up from the F, so F equals 4.94 with 2 and 12 degrees of freedom, and the p-value was 0.027. So once the blanks are full, there was a significant amount effect of an introductory to special education course on students' scores on the CAMI at the PO5 level for 3 conditions, with F at 2 and 12 degrees of freedom of 4.94 with a p-value of 0.027. And then if we have the post hoc tests, a post hoc comparison using the Tukey HSD test indicated that the mean score for the sugar condition was significantly different than the no sugar condition. So we're using the mean of 4.20 and the standard deviation of 1.3. So that's how we would report that there. As far as how we write up the data analysis procedures for this, data analysis, well, that didn't help. The easiest way that I have found is I look at other people's data analysis plans. So I'm going to put in here ANOVA and reading. Well, I could spend all day on this video searching for an analysis plan, and I'm not going to do that. What I'm going to do is I'm going to look under old course files, because I believe I have example studies, but of course they're not going to tell me what I want to know. Alright, well, they didn't really put this in the right place, but I'm going to go ahead and show it here because it is a decent data analysis plan. So what you want to make sure of is that you talk about the things that you are doing. So you're doing they're using a MANOVA here, which is multivariate analysis of variance, and the difference between an ANOVA, a one-way ANOVA, and a MANOVA is that if we had a bunch of, let's say, depression inventories, and we didn't want to do an analysis on each one individually, we want to group them all together. So what a MANOVA will do is it'll actually allow us to group all of those depression inventories into one overall depression inventory. So you'll have like the CDI, the BDI, the SADS, KSADS, bunch of different ones. It'll group all of those into one larger construct of scores, and then we would be able to test it in much the same way that we would be able to test for an ANOVA. So one of the things that we want to do is we want to make sure that, and they haven't done it here, but you want to be very systematic in your step-by-step approach. So you want to say, you know, what software you're using, what and what version. So you'd put the R statistical package, and then in parentheses next to it, you'd put the version next to it, and then you would step by step, you know, say that we examined the assumptions and it met our criteria, and then we did an ANOVA where we used school as the factor, and then we used scores on the post-test of the CAMI as our dependent variable, and just really step by step to go through it so that someone else could run the same analysis on the same data.